I'm rereading the shaman pages at modellandcards.com, and I'm inclined to uh, do an talk impromptu about logic, mysticism, if you will, and quantum physics. And the Model and Dictionary, one of the things that I keep thinking that I need to address at some point is that I talk about the quantum leap being a jump, a quantum a switch of the subatomic particle from an orbit x to an orbit not x. The reason that uh, quantum physics is so apt as a subject for connecting reality with mysticism, and it's connected to the things that I talk about, infinity and logic in the sense of distinction, either X or not X. I was gonna say that well, if you go from point A to point B, let's say that point A is New York and point B is Los Angeles. Actually, let's say that, let me do it this way. Let's say that point A is Mercury, the planet Mercury, and point B is the planet Venus. Both planets are orbiting around the sun. Now, even a kid will wonder at some point, most children wonder at some point, you know, what's between one and two? When I address the question of, okay, it gets infinitely, whether I'm talking about the infinity within 0.000000004 and 0.0000005 and how that can go on forever, or I talk about how if you magnify a square pixel of a quote unquote infinitely, there is no edge, and essentially points and lines and corners don't even exist. And what is square, what is round? There's a lack of edge. Logic has to do with the distinction, and I argued the awareness of the distinction between X and not X, just like we can distinguish between the planet Mercury and the planet Venus. And we know that if we're going from Venus to Mercury, we have to cross the space a step at a time, if you will. With quantum leaps, one way of thinking about it is that instead of taking a spaceship and making the quote unquote gradual transition from the planet Mercury to the planet Venus, if you make a quantum analogy, suddenly this subatomic particle, when it's making a quantum leap, is it's not like it's moving from the planet Mercury to the planet Venus. All of a sudden, the subatomic particle that was on planet Mercury is on planet Venus. In terms of subatomic structure, what you're talking about is that just like with the solar system, you've got the sun at the center, which you could do an analogy with the nucleus of an atom, and you've got orbits that are these paths that, in the case of planets, their planets are going around the star, the sun. In the case of an atom, the subatomic particles are going around the nucleus of the atom. In the case of quantum physics, a subatomic particle doesn't travel, at least as far as what we can perceive, doesn't travel from one orbit to another orbit. The subatomic particle either is in one orbit or it's in another orbit. It's kind of like, at least as far as, like I said, like I think I said, as far as our human perception, it's almost like it settles the issue of what's between 0.04 and 0.05, and it says there is nothing in between. Either you're at 0.04 or you're at 0.05. Now, our common experience is that no, you can have 0.04, 0.041, 0.042, 0.043, 0.045, and after you get to 0.049, you get to 0.05, but then infinitely you go 0.0411, 0.04111, etc., etc., etc. And in essence, what the subatomic particles are doing are, from our observation, they're going, no, we just go from 0.04 to 0.05. There's no such thing as 0.04 something in between 0.04 and 0.05. Forget 0.04, just go from 4 to 5. They're saying there's nothing between 4 and 5. The subatomic particle is either on 4 or on 5. The subatomic particle is either on the planet Venus or it's on the planet Mars. For that matter, it could be on the planet Neptune or maybe in some other galaxy. What I find fascinating about it is that even though you could argue that, well, we just can't measure that. Our human ability doesn't go up to that level, and you could argue that to us it looks like it's going from 4 to 5. To us it looks like it's going, it's jumping. All of a sudden it was on 4 and it went on 5, or it was on 4 and it went on 10, and it skipped the steps in between. But it's just because we can't measure it. Hold on a second.